Hi and hello to everyone. In this video, we are going to see about the various types of system. Particularly, we are going to investigate what is a linear, non-linear system, time invariant and time variant system, static system and dynamic system, causal and non-causal system, invertible and non-invertible system, stable and unstable system. Welcome to the lecture. First, we start with the linear and non-linear system. A system is said to be linear if it obeys superposition and homogeneity principle, right? What is superposition? Right. First, let's see what is a system, right? I already explained what is a system in the previous videos. Let us again repeat. Let us take a system S. The input is x of t, output is y of t. Input is represented by the notation x of t. Output is represented by the notation y of t. Okay, so x of t is processed by the system S, capital S, and it is giving the output y of t, right? Now we will see what is superposition. We are taking the system S, we are giving the input now x1, right? So the output we give the name y1. Next, if we give the input x2, we give the name of the input as x2, the output we give the name y2. Look what I am doing now. Now I am giving the input as the sum of past two inputs, right? What is the past input x1 and the other input is x2. I am going to add these two inputs. Now if I get the output y1 of t plus y2 of t, then I can say this system S is obeying superposition principle. Okay, that is very simply speaking, individual inputs gives individual outputs. Sum of individual inputs gives sum of individual outputs. Then I can say that system is obeying superposition principle. Okay. Right. Then what about homogeneity? Homogeneity is nothing but I am incrementing, I am multiplying input x1 with A, multiplying input x2 with B. Thereby the output, what is happening, you can see input x1 gives y1. Now what I am giving? A into x1. So the output becomes A into y1. Similarly, input is x2. Okay, I am multiplying the input with B, constant B. Thereby the output is B into y2. This principle is called homogeneity. Right? If a system is satisfying both superposition and homogeneity, then I can say the system is a linear system. Okay, look at this example. This is the element resistance resistor we know. We know by Ohm's law V equal to IR. I am taking this V. Let this V be the output. V be the output Y of t. I be the current, that is the x of t. Okay, right? So now we can see V y equal to R into x of t. So this is a linear system. It obeys both superposition and homogeneity. And one more important observation, if we make A as 0, B as 0, what happens? A is 0, so y1 of t into 0 is 0. B is also 0, so y2 of t into B is 0. So the output A is 0, B is 0, output is 0. So for any linear system, when the input is 0, the output should be 0. You can observe here V equal to IR. When the input I is 0, voltage is also 0. So if you look at the plot which I have plotted between the input and the output, definitely you should pass through the origin. What this origin indicates? X of t is 0 means y of t is also 0. Okay, when the input is 0, output should be 0. So any linear system will definitely satisfy, will pass through this origin. Okay, input and output relation will pass through the origin. Okay, if you look at the examples, you can get better idea. We'll look at the examples next. Okay, let us take a system y of t equal to 3 into x of t. We are going to check whether it is linear or non-linear system. Okay, first we are taking the input. Let the input be x1. When the input is x1, what is the output? y1, right? And see how you read this equation. Y of t equal to 3 into x of t. What is the meaning? Output is equal to 3 times of input. Output is equal to 3 times of input. Input is x, output is y. Okay, so if the input is x1, I give the output name y1. So output y1 is equal to 3 times of x1. Similarly, next I give the input x2. So the output y2 is equal to 3 times of x2. Now I am combining both the inputs. What is the relation? Output is equal to 3 times of input. Now what is the input? X1 plus x2. So output is equal to 3 into input x1 plus x2 multiply 3 inside. 3x1 is nothing but y1, 3x2 is nothing but y2. So sum of two inputs is equal to output is equal to sum of individual outputs. Thereby it is satisfying what principle? Superposition principle. Okay, next let's check whether we are satisfying homogeneity. What about homogeneity? A into x1 plus b into x2. So A into x1 means what happens? See, the input is A into x1 plus b into x2, right? So what is the output? Output is equal to 3 times of input. So this is the input, right? So 3 times of input multiply with 3 inside. So 3x1 is nothing but y1, 3x2 is nothing but y2. So homogeneity principle is also satisfied. That is, when the input is multiplied with A, output is also multiplied with A. When the input is multiplied with a constant B, output is also multiplied with a constant B. This is called homogeneity. So the given system is a linear system. The given system is a linear system. That is, it is satisfying both superposition and homogeneity. Okay, look at this example. I am saying output y of t is equal to 4x square of t. What is the meaning? Output is equal to 4 times square of the input x square of t. Okay, I want to check whether it is linear or non-linear. So what I am doing is, first I give the input x1. So what is the output? Output is equal to 4 times of input square. So 4 times of input is x1, so x1 square. Next I give the input x2. Output is equal to 4 times of input square. Here the input is x2, so x2 square. Next, I give the sum of two inputs, x1 plus x2. So y of t equal to 4 times of input square. What is the input now? x1 plus x2. So x1 plus x2 whole square. On expanding, I will get this, right? That is a plus b whole square. So x1 square plus x2 square plus 2 x1 x2. So I have multiplied with 4 inside, right? So this is definitely not equal to y1 of t plus y2 of t, because this is y1, this is y2. We have a very additional term. Because of this term is a new term. Okay, so I can say this is not equal. So I can conclude that the given system is non-linear. Moreover, you also can see here, right? This is non-linear relation. Square and all, square, cube, square root. Output is square terms, cube terms, square root. Y of t equal to 4 square root of x of t. Y of t equal to 4 into square root of x of t. This is also non-linear. 4 times of x cube of t. This is also non-linear. Okay, these are all non-linear, right? Next, we'll move into the time invariant and time varying system. Okay, right. If you go by the name itself, time invariant. Okay, the system is going to be the same whatever time you operate. This is called time invariant. It's not going to change, right? Practically, you think about it, right? You are purchasing, maybe I can say you are purchasing a mobile phone, right? The day you are operating your mobile phone, how far it is good, how good it is operating is to be the same even if you operate the mobile phone after 1 year. Okay, so if you say, well, the day you purchase it is operating superbly, after 1 week it is not performing well, then I can say it is a time varying system, because the performance of the mobile phone is getting reduced with the varying of time. Okay, if it is a time invariant system, it is going to be the same, right? Assume your mom is cooking food, right? She is taking 10 minutes to cook idli, right? She is keeping the idli pan, idli cooker for by 6 o'clock in the morning. She is trying to cook. By 6:10, idli is ready. If she starts cooking at 9 a.m., by 9:10, 9:10 a.m. the idli would be ready. Whatever time she starts cooking, it takes only how much time? 10 minutes to cook an idli, right? That's what I say. It is a time invariant system. Such systems are called time invariant system. Okay. So you give the input. Let me put it like this for you. Let me say this is your x of t input, right? I give a input. I get a output. This is my y of t. Next, what I am doing is the same input I am delaying t minus 2. Okay, so I have delayed the input by 2. You can observe. See, the input I have delayed by 2 units. So what happens to the output? The output will be also delayed by 2 units. Okay, right? So simply speaking, if I give the input x of t, some random signal I am giving, I am getting an output, right? Y of t. What I have done here, I have delayed, excuse me, here I made it. Output is also delayed. T minus 2. Okay, right. So now I have delayed the input by 2 units. The same signal is delayed here, right? So what happens? Output is also delayed. This is the output. It is starting at 0. Now it is starting at 2. Okay, such systems are time invariant system. Okay, this input gives the output. If input is delayed, output is also delayed, right? Practically all systems are, we will take it as time invariant system. Think about whether human beings are time variant or time invariant. You start studying in the morning, right? You take 1 hour to complete 10 pages to 10 pages to study. You need 1 hour, right? The same thing you are doing at night 11 o'clock. How you may, for reading 10 pages you may need 2 hours. So we are definitely time varying. Okay, our performance varies with respect to time. Okay, but if you take any system or ideal system, definitely it should be time invariant. For that mathematical derivation purpose, I am explaining like I take a system, yes, giving the input, I get the output. What I am doing, I am delaying the input by k units, t minus k. That's a time delayed input. I get the output, time delayed output. Next I am going to find t comma k. What is t comma k? Is nothing but replace wherever t with t minus k. Right? So what I'm delaying the input, I'm seeing the output. Next I find out y of t comma k, that is nothing but wherever t is there, I will replace with t minus k. If y of t minus k and y of t comma k are equal, then I say it is time invariant system. If they are not equal, I'm going to conclude it is time varying system. Okay, let's see here now. Check it out, whether it is a time variant or time invariant system. Output is equal to 4 times of x of t, right? So first what I have to find? I have to find y of t minus k. What is y of t minus k? In the previous slide we had discussed y of t minus k is nothing but when the time delayed input is given, I will get the time delayed output. Okay, so I will delay the input time. Okay, input, what is input? X of t. I'm going to do x of t minus k. I will get y of t minus k, right? Next I will find y of t comma k. What is y of t comma k? Replace all t with t minus k. Wherever t is there, replace with t minus k. So this is my y of t comma k. I have to check whether t minus k and t comma k, y of t minus k, y of t comma k are equal. Yes, they are equal. So it is a time invariant system. Okay, look at another example. Y of t equal to 4t into x of t. What is the meaning? Output is equal to 4 into time into input signal. Okay, first step, I am going to find y t minus k. T minus k is nothing but time delayed input. X of t is delayed, I will get the time delayed output. Okay, time delayed output is obtained by time delayed input. Next, t comma k I am going to find. What is t comma k? I have written here, replace all t with t minus k. So t is there, t minus k, t is there, t minus k. Check whether these two are equal. They are not equal. Here you have t, here you have t minus k. So it is a time varying system. Easily I can find, if you can, easily I can conclude time varying or time invariant by, if there is time outside the input. This is the input, x is the input. If you can find t outside the input, okay, then I can say it is a time varying system. Okay, here input is there, there is no time outside, so it is time invariant. Here you have time t outside the input x of t, so it is time varying system. Now, we will find out that we will take an electrical system. We will find out whether it is a system equation, right? The system, how to write the system equation, right? Okay, this is a simple RLC circuit. They are connected in series. I have given a voltage source V of t, and the output is the current. So, input is the voltage, output is the current. So, input is x of t. Generally, I will take x of t. X of t here is V of t. Output is y of t. Here, output is equal to current. So I am going to write Kirchhoff voltage law KVL for this loop. So this voltage V of t equal to sum of voltage across the resistor, voltage across the inductor plus voltage across the capacitor. Voltage across the resistor is IR. So voltage across the inductor is L di by dt. Voltage across the capacitor is 1 by C integral of I dt. So to remove the integration, I differentiate this once. So I will get this expression, right? First time differentiation, then it is d square, then integral differentiation gets cancelled out. Okay. Now I can replace with what is V of t? V of t is the input. Input with x of t. What is I of t? I of t is the output. Okay, I of t is output. This equation is called system equation. Why it is called system equation? Because it gives a relation between input and output. Because the input is x of t, output is y of t. They are related by this equation. This equation is called system equation. Okay. Now, very important thing. Yes, the system which satisfies both linear and time invariant properties are called linear time invariant system. LTI system. LTI system. Theoretically, in your subject, in your undergraduation, you will be always studying about linear time invariant system. Linear time invariant system. This expression is a linear time invariant system. We know differentiation, this is a linear operation. Integration is also a linear operation, right? So they are linear time invariant. This is a linear time invariant system. Okay. Now, suppose in this expression you can find the coefficients. What is the coefficients of dx by dt? It is 1. What is the coefficient of dy by dt? It is r. D square y by dt square it is L. Y, the coefficient is 1 by C. Here the coefficients are independent of t. We don't have t here. That is the reason we say it is time invariant. Suppose if we have t here, okay, if we have a t here, then I can say it is time varying system. Okay, that's what I mentioned here. If the coefficients are functions of time, then it is a time varying system. Here we don't have time. Okay, with this, okay, here we don't have time. So this equation is a linear time invariant system. Suppose if we have t here or here or somewhere here, then I can say it is a linear time varying system. Remember, in your control system, in your signal system, or next semester you'll be studying about control system. There we'll be always studying about LTI system. We are not going to study about time varying system. We are always going to study only about time invariant system. Okay. Next we move into something called dynamic and static system. Okay, what is dynamic? Dynamic is nothing but other name for dynamic is memory. Static is memoryless. Okay, a dynamic system, the output depends on past or future or both. Okay, right? Such systems are called dynamic system. Okay, human being or dynamic system. Why? Because we are in the 2020. How do you know we are in the 2020? Because past year is 2019, the year before is 2018. So we know we are all dynamic system. Okay, right? So for a system, the output depends on the past or future. We say such systems are dynamic system. Static system. Static system is output depends only on the present input. Okay, such systems are called static system. Look at this example. You get a clear idea. What is this meaning? Y of t equal to 4x of t. What is the meaning? Output is equal to 4 times of input. Output is equal to 4 times of input. Okay. Suppose I need the output at time 1. Time 1. What I have to do? 4 into x of 1. Right? So output at time 1 is equal to 4 times of input at time 1. So output at any time depends on the input at that time only. Okay, present input same time. Okay, output at time 2 depends on input at time 2. Output at time 4 depends on input time 4. So such systems are called, this is an example for static system. Okay, look at this example. Y of t equal to 4 into x of t minus 1, right? Okay, so what is the meaning? Output is equal to 4 times of input at the time minus 1, right? Okay, let me put time 1. Y of 1 is equal to 4 into x of 1 minus 1 is 0. If you observe this, I need the output at time 1, but it is equal to 4 times of input at time 0, past input. Okay, right? Similarly, if I need the, let me say time 5 equal to 4 into x of 4. I need the output at time 5, but I need the input at time 4 into 4. Okay, so it depends on, output depends on past. Output depends on past input. So it is an example for dynamic system. Dynamic system. Okay, look at the third example. Y of t equal to 4x t square. Okay, this is different from, don't get confused between x square t with x t square. They are different, right? This is signal is squared, here only time is squared. Okay, both are different, right? Here this is signal is squared, x is squared, here only the time is squared. Okay, now try to answer whether it is static system or dynamic system. Okay, let me say at time 1 is equal to 4 into x of 1. Okay, if you look this, it may look like static because output at time 1 depends on 4 into input at time 1. Okay, check for some other time. Y of 2 is equal to 4 into x of 2 square. 2 square is 4. So output at time 2 is equal to 4 times of input at time 4. Future. Okay, I need the output at time 2. I need the future input. Similarly, if I need the output at time 3, I need the input at time 9, x of 9 into 4. So it depends on future inputs. Such system, this is also an example for dynamic system. Okay, next we'll move into causal and non-causal system. What is causal system? Here one important thing, don't confuse with causal signal, right? Causal signal is different, causal system is different. Causal system relates input and output. System is only system relates input and output. Okay, if you can see the system, it relates input with output. But if you take a signal, it will have only x or only y. Okay, don't have x and y together. Okay, so a causal system, the output depends only on the past and present input only. Non-causal system depends on the future input. Okay, very important, right? See, practically, the output depends only on the past and present. Okay, how you are performing in the exam. Okay, you have an exam tomorrow. If I say like that, what is your performance? Your performance depends on what you read before, past input, as well as how you are doing at that time. Okay, so output at any time depends on past and present input. Such systems are causal. What about non-causal? Output depends on future. Okay. Okay, I can say one profession is non-causal. Only one profession is non-causal. That is astrology. What does astrologer does? Astrologer will be saying that you will become a scientist one day. You will become a great person one day. He's predicting. He'll say the output depends on the future. Okay, right? So a causal system output depends only on the past and present input only. For a non-causal system, output depends on the future input. Look at this. What is y of t? Output is equal to 2 times of x of t plus 3 times of x of t minus 4. So it is very clear, output at any time depends on the present input as well as t minus 4 past. Okay, so it is an example for causal system. You can check it, right? Let me take t equal to 2. So t equal to 2, 2 into x of 2 plus 3 into 2 minus 4 is minus 2. Output at any time 2 depends on input at that time as well as input at the previous. Before 2 only minus 2 is there, right? So it depends on present time as well as past time. So this is an example for causal system. Causal system. Okay. Next example, y of t equal to 2 into x of t plus 1. T plus 1, right? Okay, let me say, if we put t equal to 3, so it becomes y of 4, sorry, y of 3. Y of 3 is equal to 2 into x of 3 plus 1 is 4. So output at time 3 depends on 2 into input at time 4. Future input, I need the output at time 3, but I need the input at time 4. Output y of t also depends on future input. So this is an example for non-causal system. Non-causal system. Okay. Next is, look at this example. Y of t equal to x t square. Right? Let me put t equal to 2. Y of 2 is equal to x of 2 square is 4. So output at time 2, if I need the input at time 4, I need future input. So this is also non-causal system. This is also non-causal system. Next is invertible, non-invertible system. If you go with the name invertible, you can invert, you can convert, right? That's invertible, right? What I can say here is, I take a system S1, I give the input X, I get the output Y. I pass through another system S2, thereby I will get the same input which I have given as the output. This is called invertible. I can see the analogy, I give the analogy like you take a tumbler of water, put it in the freezer, what happens? It froze to an ice, right? You put it back in the sunlight, what happens? It converts back to water. Such systems are called invertible system. You get back the input, right? You get back the input x of t. Okay, right. What I am doing here, what is the meaning of this? Output is equal to input plus 5. Output is equal to input plus 5. Right? So, is it invertible or not? Yes. Let me do it like this. The system is going to give plus 5. So if I give the input x of t, what is the output? Y of t equal to x of t plus 5. Okay. Next I am going to give minus 5. Another system operation is minus 5. So x of t plus 5 minus 5, I will again get x of t. Okay. So this is an invertible system. I will get back the input. So what is doing? See what I have done here. Input is added with 5. So if I make a system where I can subtract 5, I'll get back the input. Such systems of this is an invertible system. Okay, right. Look at this. Y of t equal to x square of t. Right. So any signal is squared. I get the output. Okay, whether it is invertible or not, let's check it out. Let me say x of t is equal to 2. So what is y of t? Y of t equal to 4. If I can pass this y of t to a square root system, sorry, to a system where I can square root, what answer I will get? Square root of 4 is plus or minus 2. Here it's not clear that I should get plus 2, but it can be also minus 2. So this system is non-invertible. Okay, people immediately think, sir, square is there. If I take square root, I can get back x. Yes, of course you can get the x, but there are two options. Even plus x is, even plus 2 square is 4, minus 2 square is also 4. You have two chances, right? I have to get a specific input. I have to get only 2. But what are the possibilities? Plus 2 and minus 2. So this is not this is non-invertible system. Okay. Right. Next we'll move into stable and unstable system. In stable and unstable system, what we're going to see is we look at a term called bounded input, bounded output. Bounded input, bounded output. What is bounded? Bounded means finite. Bounded means finite. Mathematically, I can say it is less than infinite. Input is less than infinite. If I give input is less than infinite, I will get the output y of t that is also less than infinite. So bounded input gives bounded output. Such systems are called stable system. Look, whether it is stable or not. If I take x of t, let me say bounded input, x of t is 2. So what is the output? X of t equal to 2. What is output? Y of t equal to 8. So I give you bounded input, I get the bounded output. So it is a stable system. Remember, you have to check for all possible combinations, right? This example will help you. Okay, look at the second example. Output is equal to 4 divided by the input. 4 divided by the input. Okay, let me take x of t equal to 2. What is the output? 4 divided by 2, the output is also 2. Okay. Let me take x of t equal to 3. What is the output? 4 divided by 3. Okay. Now it is looking like, sir, I have given bounded input, I got the bounded output, bounded input, I got the bounded output. But what about this case? X of t equal to 0. What happens y of t? 4 divided by 0, I will get infinite. Okay, so the 0 is bounded, but still you are getting the output is infinite. So definitely this is a unstable system. For all possible cases, it should work, right? Here if you see, for these two cases, it may look like stable system. But if you have to check for x of t equal to 0, then you get infinite. By experience, you can understand. By solving more problems from a textbook, exercise problems, you get an idea, right? So definitely this is an, second one is an unstable system. Okay, let us go into the third example. What is the meaning? Output is equal to integral of x of t dt. For where I am integrating from minus infinity to t. Let us take x of t equal to 1. X of t equal to 1. Whether it is bounded? Yes, 1 is less than infinite. This is bounded. What happens when I integrate minus infinity to t? 1 dt. So it is t, limit is minus infinity to t. So it is t minus of minus infinite, t plus infinite. So the answer is infinite. So we gave a bounded input, but since the time is from minus infinity to t, it becomes, output becomes infinite. So it is a unbounded output. So this is also, third is also an unstable system. So instead of minus infinite, if it is between the time t1 and t2, okay, if this is not, if this is between t1 and t2, the result would be t2 minus t1. In that case, it is bounded. Okay, be clear, right? Very limits are very important. Okay, right? So if it is the limits is between t1 and t2, it becomes a stable system. If the limit is between minus infinite and to minus infinite to t, then it becomes unstable system. Okay. Okay, I hope you learned something from this lecture. Thanks for listening. Do subscribe the channel. Any doubts, please ask in the comment section. Jai Hind.